And up here on the site, I've got a document that Brett's put up that's pretty similar to that checklist, and you can grab that and take that away with you if you like. And it's going to go through pretty much some of the things there that you're going to deal with, you're going to come across in the exam. So you need to make sure that you're familiar with these things. I was spending a little bit of time before tonight's lesson going through some of this with some of the early attendees. And so you can see there's two quizzes. One's more essay answers, which are going to be some explanation from you about the different questions that have been proposed. And here's an example of 8 there. So for example, soil classification. Would you know where to find soil classification? I'd suggest you probably put this on your computer, or you can use the one that we've already got on the computer there for you. It's the same type of information. This is possibly a little bit more specific now that we're close to the exam, and make sure that you can locate and discuss all the different things on here. So we've got soil classification. You should know where to be able to find that information. And that's pretty straightforward. If you just go to the National Construction Code, I think I've got one open here, and here we have table 3.2.4.1, and that's got information there on our soil classification. Okay, so you need to be able to find the information and know which documents to find it from. Natalie, that's Brett. Brett, that's Natalie. So hopefully you feel confident to be able to look to the right document to get your information. Michael, that's Brett. Brett, that's Michael. There you go. So yeah, they could have all come in at once, but yeah, that's all good. So pretty much you need to be able to find the source documents and quickly search your way around them. The National Construction Code is quite a few hundred pages. You can see that's 600 pages, this document. So you're not going to find that real easy, things in there real easy, unless you've got a quick way to be able to jump around them. So here we've got the footings and systems is 2870. If you go to the Australian standards and type in footings, you'll find it'll give you the number there in case you've forgotten it. But I would recommend that you write those things down ready for the quiz. And then we can look at some of the different things that are through there, and they've been covered in the lessons as we've gone through. You can see there's an example of some of the other parts, and then down the bottom here's an example of some of the documents that you might want to make sure you've got accessible and ready to go on the night. You can see even things like prior to span tables, bushfire attack level listing, James Hardie documents, some of those things. So if we're dealing with a product that's not a generic product that's been manufactured by a manufacturer, then they are going to have the source document for that, the technical details. Okay. And tonight, what we want to have is a little discussion on, quick discussion here on the National Construction Code. A quick look at some information that's been put up on here. So in the National Construction Code, there's a whole suite of information. And you can see from when we click on there, we've got the full suite, the 2019 suite, and there's other documents and things that are on there as well. We can have, for example, performance solution scenarios that have been developed to assist building practitioners for things like converting a farm shed to a habitable dwelling, and something that's a little bit unusual that may not be shown specifically in the main construction code. So there's some information there about that for you to have a bit of a look at as well. And then there's more than just volume 1 and 2. Okay. So we've got access to Australian standards. Remember that at the top of every page for structures, we've got some links there for you that'll come up on every page, and that's where you can find the best one that suits you, and then save it somewhere on your computer so you can find it real quick, because you're going to need that. Okay. So what we want to spend a little bit of time doing now is having a look at two more things, like the message that I sent you out to you today. We're going to cover today alpine regions and also bushfire attack level. That's real appropriate at the moment because we've been having so many bushfires across the state. In fact, the eastern part of Australia, pretty much all the mountainous area from probably north of Brisbane all the way down towards the Blue Mountains, has probably half of it's been burnt out. If you have a look at the maps on the different fire sites, someone was saying that last year there was about 100,000 hectares that was burnt out, and that was through the whole fire season. This year there's over 1 million hectares burnt out, and it's only the middle of November. So it changes from time to time, and that's why things like the National Construction Code come into and deal with some of these things. So we're going to have a look first of all at alpine regions, and then we're going to have a look at the National Construction Code and see what it has to say about bushfire attack areas. If you look at the National Construction Code, it's got a whole part there on alpine land, and that little screenshot there shows you from just a screenshot of the area, but I want to go right to the document, to the National Construction Code, and show you how you can find that yourself. So I'll just shrink up all of the things and stick onto the title bars here. And as you come down, you can see there's a whole lot of state and territory variations. Our performance provisions and acceptable construction are a couple of real important parts there. And as we look at these and expand them out, they'll have more information there on the things that we're looking for. And as we go down through here, we'll find they're going to deal with our alpine areas. So we'll just grab that reference there, volume 2, part 1.1. And pretty much, if you're not sure on the exam, if you type in a fairly limiting search word there, you'll find that it'll come up with the answers to these types of things. I'll just make a bit more room across here, and you can see that we've got alpine mentioned a few times. We've got alpine areas, and this part here shows us some areas. This takes us straight to the alpine areas in the National Construction Code. We'll just get a little bit more width here, and I'll show you what that means. So when we look at alpine areas, they're going to be areas of land that are shown on the map here throughout New South Wales and Victoria, and there's categories there for them, and they're going to be, and Tasmania has some as well, and pretty much it says anything greater than 1,200 metres in height in New South Wales, ACT and Victoria. And then as we go down to Tasmania, because that's gets a little bit colder, anything greater than 900 metres. So if you were to look at a topographic map of those areas, those places, if you saw anything to any of those heights, then that's what we call an alpine area. Okay, we did a quiz on this, I think, the other week, and we looked at some towns and said what was their area, and that's pretty much where we get that from. So there's lots of information in the code about alpine areas. That's just the definition part. We keep working our way through. You can see it's got all the blue words that are in the National Construction Code. They link to a definition, and there's quite a few there for alpine area. And then as we go through, we come to more information here. We come to this one here, which that's our climate zones. Keep working our way down. We come down to that term is used quite a bit, and then we come to construction in alpine areas, and I think that's linked so that it'll go straight down to part 3.10.4. So you'd probably make a note on your little Word document if you had it there. For example, for alpine areas, if you saw the alpine area there, and you'd make a note that we want to make sure we go to 3.10.4, so you can find where that is for the quiz when you get your quiz question on it. And so it's going to say there, compliance with this acceptable construction practice for buildings that are located in alpine areas satisfies the performance requirement. And then it'll talk about things like doors. External doors that may be subject to build-up of snow must open inwards or slide and be constructed so that the threshold is not less than 900 mil above the adjoining surface, because you might have 900 mils of snow, for example. In a Class 1B building, be marked open inwards. So that gives you an example, some of the types of things that are a bit different. You've got to know all that. If you go to build a building above 1,200 metres, for example, then that would be something that's different on the plans that you would need to look out for and make sure that that's been done. Now, your draftsperson should automatically do that, whoever draws up and designs the plans, because at the moment you go and get a set of plans and you look and see which way the door swings, and that's what determines where you put the hinges on the doors and how you install it. We'll just be aware that in alpine areas it could be a little bit different because of some of the different characteristics of those areas. External trafficable structures, external stairways, ramps, access bridges and other structures must have a floor surface that consists of expanded mesh. Okay, if it's used as a means of egress. Egress means exit from the building. And any required barrier needs to be not less than 75% open. Any suggestions as to why you think that might be? Why might we want to have mesh and open barriers on our, if we're using a traffic area as a means of getting out of a building? I think it makes sense, even though you've probably all gone to sleep and nobody's chatting. The answer to that, correct answer to that, would be so that the snow can hopefully fall through it and we can get some grip as we walk in and out. So there's quite a lot of information there. Clear spaces around buildings. Okay, we've got quite a few different scenarios that we need to be aware of with alpine area building. All right, need to make sure that we're familiar with the code and we understand how we're going to build, so that we make sure that there's room. Mostly when there's needs to be room around buildings, it's designed for emergency vehicles and for fire separation and things like that. Okay, they're some of the main reasons we want to have some clearance around buildings. So we'll just jump back here. I'll turn on this map, which I've just showed you, which is pretty much the Alpine regions map. Okay, so you can see that's just taken straight from the code. It's got a whole bunch of towns listed there. Mansfield's listed in there, number 32. And Mansfield does have a little bit of height about it. What's the next one there? 33 is Mount Beauty. Pretty much people stay at Mount Beauty because it's never really snow bound, but it is high enough to be it's a subalpine area where snow loads are not significant, but these areas listed through here are close to the alpine areas. So it says here we've got alpine, subalpine regions where snow loads are significant, and we're going to have to plan for that when we do our building. Okay, so let's just have a quick look. Here's a brief discussion. So Brett just said doors have to swing an opposite way for an alpine escape. You may have noticed that when we looked at the National Construction Code, it said one of the things was doors swing inwards. In a class, I think it was for any clearances around buildings, it was up here where it talked about external doors. External doors that may be subject to a build-up of snow must open inwards or slide. And obviously opening inwards means if it's full of snow on the outside, you can't open the door outwards and you couldn't get out. So that's why we open it inwards. Whereas normal buildings, we would have the door so that it opens outwards so we can get out quickly. Or specifically buildings that are where people might be in the building who aren't familiar with the access routes in a building. Okay, if it's a building where, like a public building, normally the doors open outwards because people can just run and open and go. They don't have to stop, bank up on the inside and try and open a door. So in this particular case, it's not practical to have the door open outwards because there might be a heap of snow out there when you wake up in the morning. Now there's this Build Right toolbox here, which is pretty helpful for you. This one for I'm going to actually pin that up the top here so that I've got this for, and you can just pop it onto your bookmarks bar yourselves up there. Here it is. And I would recommend that you pop that up there somewhere ready for the quiz, because this has a lot of good information for some of your questions in your exam. But this pretty much just shows us some of the details there on the alpine areas. Okay. So when you go back on this, you'll get to the main part, which deal with loads and forces. So that'd be a really good one to put on to your onto your little favourites bar up the top there. Just ask someone how to do that so that you're all ready for your exams, because there's a few questions that ask about that. The next little part here that I'm going to open tonight is your fire safety in alpine regions. And so we'll just fire this up, pull this over to the side. The question there is, can you find the acceptable construction part for alpine regions within NCC Volume 2? And what is the subalpine area? I think I pretty much just showed you that. But if you look at that, we talked about some of those areas, a building in an alpine area, and we talked about the fact that we need to have our doors possibly opening another way, and we need certain types of ramps and things like that. So this is in our acceptable construction in Volume 2. Volume 1 of the National Construction Code would have the same type of thing. So when we're just having a talk in class here about how that when you're in the alpine region, you've got to have your frames and trusses a lot stronger, and that's actually spoken about in the code. But also when we look at that Build Right toolbox that I had there, so I'll just open that up and show you that. Here it is here. And when we look at the alpine areas, It's just like remember we spoke about there's different types of loads. In fact, here you can see the main types of loads. This one here, and we've got our primary, secondary nature of loads and things like that. And if you look at your loads, some doesn't actually work on Google Chrome, but you have your when you have your loads, you pretty much have I think here we are here. You've got dead loads and live loads, and this is an example where this is one of the loads that we have to take into account. Okay, so these areas require compliance to the BCA for external doorways, ramps, access bridges, access for firefighting vehicles. We've got to make sure that we meet all these requirements. As I said, your designer should plan for that and should have that all set up for you so that you just build according to that. And when we look at the alpine areas, I think we've already put information on that there, so that's all good for you. So that's pretty much your alpine area. Let's just check here. I might just continue with the word alpine here, and I would recommend that you just whiz through here and have a bit of a look at all the times that it mentions your alpine areas. Maybe even have a look at snow load. Just have a bit of a look through some of these, this 500-600 page document, and see what some of these things speak about. So you can see here it'll give you a bit of a context when you look at it. Make sure that you've had a bit of a look at this document and make sure that you're familiar with some of the different loads. Okay. And there's some of your main areas. They're probably your main towns where you have to be aware of that. There's not too many towns once you get up too high. I think Cabramurra is the highest town in Australia. That's map identifier number 5. Nice little drive up to there. It's up in the middle of the mountains there. So pretty much when you go to Cabramurra, you'll find the buildings are quite unique, and they have, if I just show you a quick picture of Cabramurra, oh, here we go. Probably spelt that wrong, not sure. There we go. So with Cabramurra, one of the first things you're going to identify, grab the images here. One of the first things you're going to identify with Cabramurra is that the roofs are quite steep. So you can see there, and I'm not sure if anybody's been to Cabramurra, but when you go inside the main building there, which you're most welcome to do anytime, then you'll find there's massive big beams on these roofs, and they're real solid rafters all the way across there. You can see they're pretty steep right across there. So I've stayed in those buildings, and they have all double glazed windows, and it's just because they get quite a bit of snow load through there. There's a lot of central heating. There's a lot of room around the buildings, so they can get fire vehicles in if they need to. They do have major bushfires up there, obviously in summer, but in winter, if they have a fire in one building, then they want to be able to get a vehicle around to be able to protect the building. So there's lots and lots of things are built quite a bit differently. We don't have the severe weather that they have overseas, but in some places overseas, it's a regulation that you always keep the pathway to the street clear in case emergency services need to get to your front door. So you can actually get fined in a lot of countries around the world if you haven't kept your pathway clear. And so what lots of people will do is when they pour their driveways, they'll put heating elements in the driveway so they can just keep it clear, and that saves them shoveling the snow. So that's we don't have it quite so extreme here, and there's very few towns in Australia that have real big heavy snow loads like that, okay, that are accessible too much by the public anyway. So hopefully you're all pretty good with that. Maybe just let me know if you had any other observations. I'd like to see who has done some work in a snow area, who's done any work in some of the, done anything that's a little bit different with snow. Let's see if anybody comes up with a chat there. Maybe just type a couple of things in the chat box, and I'll just show you a couple of things here that you get these that might be interesting for you about. I'll get rid of a couple of these little ones. There's snow load calculators. So you can see with this, with the snow that we've got on the roofs here, that can become quite significant. You can see these guys here, and some of you watch the YouTube, the Facebook videos that come up from time to time, and there's all sorts of inventions to be able to get rid of the snow off the roof. These guys go up there, lots of people with a bucket, with a big like hand cart like that, and push it off. It'll build up, and you get what's called a cornice on the edge, and that can come down and hit you on the head, and it can be quite dangerous. So look at the massive snow load on that, metre and a half deep. That's a massive load that's on the building that, if it's not planned for, can be real hazard. Now you've got the falling from height issue here, but it's probably going to be soft when they land down there anyway, so it's probably not too bad. But we can have a people invent all sorts of machines to be able to clear the snow off the roof. And if you have a quick look on at some of the different things that they have, then that'll give you an example. Quite often on the roofs, they'll put these little rails across. And my kids have just come back from 2 years over in Canada, in British Columbia, and they said those things there are to slow the snow avalanches down off the roof, so that you don't get quite so much landing on the doorways of people when people walk past. So that can be pretty big. Look at that one there. That's collapsed the building in. So buildings, it's a massive load to be put onto a building. And snow can be real sticky as well. So sometimes you can't even get it off unless you actually get some type of a system to be able to get it off. Look where it slid down there and fallen in underneath. So it's real unique when someone said it's got steel in it. It's real unique when the snow comes in, and you can see how the tentacles come down here, and it can really build up. So just to show how cold it was, my son-in-law got a boiling hot cup of water out of the urn, walked outside and threw it in the air, and it was snow when it came down. That's how cold it is over there, minus 40, minus 50 degrees. And so that sort of stuff, when it lands on roofs, you can have massive load that'll just collapse buildings. So that's really got to be taken into account when we build over there. Let's see what you've all said there. Get up to here. Needs to be structurally engineered. You can find calculators. Your engineer is going to be your best friend for things like that. Make sure that they've taken that into account. Concrete can cause problems with freeze-thaw issues. That's right. So concrete over there, even pouring in some of that country, they have to put a lot of additives in it to make it work. And they do have, just the way they build is quite a bit different over there. You can get a lot of bleed water that freezes. That's right. The surface can be real hard to get it to cure. Yep. So some parts of the country are seasonal. Brett was just saying here. I don't know, in Canada, where our kids were working on the snowfields there, it was fairly seasonal as well, where you just can't go outside without protection, because you can only be outside for 5 or 10 minutes before it gets too cold with the wind chill factor. Insulation and everything else goes up, and especially things like airproofing houses, which we spoke about the other week. We can see here, more for the fortunate people who live in the snow. Snow is great to live in until it gets real cold. Windows a lot better quality, that's right. So the windows you get over there will be quite different to what we get here. Thanks for the recording there, someone. Yeah, so the windows that you get over there are starting to come over here a little bit, and we're becoming a little bit more aware of the importance of good windows. So some of you may have used triple glazed or double glazed windows, but over on the coast you don't really have to worry too much, because it's just beautiful weather most of the year round. Let's leave snow for a minute, and let's spend a little bit of time looking at bushfires. So there's another part of the National Construction Code which deals with bushfires, and I want to go right. I'm using volume 2 because that's kind of where we live, and pretty much when there's really big bushfires, like the Ash Wednesday bushfires in Victoria and the ones that we're having currently, and anything that's fairly major, you find that the National Construction Code gets pressure to be able to implement changes so that things don't get burnt. I forget how many they said, but is it like 50 houses that have already been lost in New South Wales this year? Might have even been more, I'm not sure, but heaps and heaps of houses get burnt. So that puts up insurance premiums, and that changes a whole lot of things. And then eventually what happens is it rolls over into the National Construction Code, and the way that people build gets changed and gets altered. And so you can see here with the National Construction Code that because I've been around a fair while, and Brett and some of the others have in building as well, we would remember before a lot of this information was in. And now I know from after probably the 2000s, 2002 or something, some rules came in which said you have to, for example, have metal fly screens on the outside of your windows if you're in a building in a bushfire area, and all sorts of things like that. So let's just have a little look at what some of the things of what the code says. For example, here in Class 1 building or a Class 10A building or deck associated with Class 1 building that's constructed in a designated bushfire-prone area must, to the degree necessary, be designed and constructed to reduce the risk of ignition from a bushfire, appropriate to the potential of ignition caused by burning embers, radiant heat or flame generated by the bushfire, and intensity of the bushfire attack on the building. So there's some things there which basically says it must be designed and constructed to reduce the risk of ignition. That part there is the whole aim. You can build a building that will resist any bushfire that you could ever have, but you may not want to live in it because it might be so unlivable and have such small windows and things that it might be real hard to live in. So there's always a little bit of a compromise. And in this particular case, we're trying to build a building that's constructed to reduce the risk of ignition as much as possible. Let's have a look and see what bushfire prone area means. And I can see that's not actually working at the moment. So we'll just grab that. You might have it available in yours. That's actually a definition there, which we can look up. Don't know whether that's going to go to that one. Designated bushfire area. I only just downloaded this, but for some reason the links aren't working. There's one there. So here's the definitions right back at the beginning, or in one of the this particular case, I think it's towards the end. There's definitions, and one of the definitions in here is definition of bushfire prone area means land that has been designated under legislation or has been identified under an environmental planning instrument. I'll show you one of those in a second. Development control plan, I'll show you one of those, or in the course of processing and determination of development application as land that can support a bushfire or is likely to be subject to bushfire attack. So I'll show you where there's one of those in Wagga, and you all have these in your town as well. And pretty much what we need to look at is our online mapping, because our local government authority has already done the work for it here, and they've designated bushfire areas. In this particular case, this is just Wagga. Most councils are using these intra-maps now, and you've just got to click on that, and then you come across to the side here, and we can see in this example we've got a bushfire map, and there's a somewhere there it tells us what all these definitions mean. I think it might be here, but I know Wagga pretty good, so I'll just explain it to you rather than look at all of what that all means there. But so pretty much what you can see there is areas where there's a fair bit of bush. Now we might be able to put some imagery on top of here. I'll just see if we can put some imagery on that, so you can get a bit of an idea of. Let's put the city and the non-urban imagery. There you go. So now you can kind of see where bush is because of how it's been drawn up. And if we go, for example, to down to the south here, we've got a lot of bush down on the south of Wagga, and this is going to be land that supports fire. And if you build in those areas, you've got to do different types of things. This is actually going to take us to a spot where it tells us what all the information is. And so you would have to build your building different when you come to build in that type of area, okay? Because that's been considered to be a higher risk, where you would need to have a house that can, as it said here on the, that it's the bush is likely to support a bushfire. And so we need to make sure that our building is built in such a way that it'll stop the bushfire and give us a little bit more protection. Let's see what they say here for planning for bushfire protection. It's described in the Environmental Planning Assessment Regulation. Okay, so that's another regulation there, which will go into that. And then when we come to the bushfire, I'll just jump back here to our site for tonight. So that pretty much goes through some of the terminology. I'll open up a few of these for you so we can just consider this a little bit more. There we go. So some of the things we need to be aware of with bushfire terminology is things like a private bushfire shelter, which we'll come to in a second. And we need to also be aware of what the term FRL stands for. So this is FRL, anytime you see that, is fire resistance level. And it means the grading symbol in minutes determined in accordance with specification A 2.3 volume 1. And pretty much what it means is the number of minutes that a building can stay structurally adequate to be able to support its loads, and the integrity and the insulation. And then fire resisting is applied to a structural member or a part of a building, means it has an FRL required for that structural member or part thereof. So I'm going to show you where that talks, how we get to the FRL. So that's fire resistant level. We'll just jump up to the top here so we can get started on it. And you can see here, fire resistant level. It goes through some information there. We've got fire hazard properties. Just keep going through our fire FRL there. So in this particular example, this is a wall and it must have, for example, a FRL of not less than 60, 60, 60. So those numbers there are in minutes. That means 60 minutes for the first item, 60 minutes for the second, and 60 minutes for the next item. And I'll show you what those items are. Used to have a hyperlink to FRL somewhere, but that seems to have gone. So I'm thinking it's probably down here in the definitions, which is just there. If we go down here to F, sorry, they gave us a new computer and this mouse is a bit slower. So there's the definition of fire resistance level, FRL, and it means the grading periods in minutes determined in accordance with Schedule 5 for the structural adequacy, integrity and insulation. Okay, let's see what structural adequacy means. Definition of structural adequacy in relation to an FRL means the ability to maintain stability and adequate load bearing capacity. Okay, as determined by Australian Standard 1530. So think of it in terms of that building can stay standing, and if it was a 60, 60, 60, the building can stay standing for 60 minutes, maintaining its load bearing capacity. Okay, that's the FRL there. We'll come back up here and grab the definitions again for FRL. Here we go, I think down here. Here we go. So that's structural adequacy. Now, an example of that could be that in Tumut, there's a sawmill, which is, let's go back up there and have a quick look at this Tumut sawmill. And this sawmill has two types of constructions. It's a portal frame construction, and in this sawmill, the first part of the building has been constructed out of, that's the main sawmill just here. The first part of the building has been constructed with portal frame as you come into Tumut, that has steel portal frame. So it's basically has big steel columns. That's this part of the building here. It has big steel columns all along the side here that go up the side, across the top and down, and that's the first part where all the timber comes in. And because it has steel, it would have a certain amount of structural adequacy. But if a major fire occurred in there, which hasn't ever happened, but they've planned for it, after a little while that steel would get so hot that it would lose its strength, and so you would have a low structural adequacy for that building. So in this new building that they built out the back here that you can see, if you were to go inside there, that has big, actually I think it might have been that big one there. It has massive big glue laminated radiator pine, because this is a radiator pine factory, and it has massive big glue laminated radiator pine beams that are probably 500 or 600 or 700 millimeters wide and probably about 300 or 400 millimeters thick, and that's what the framework of that building is made out of. Same type of building, but this one has a timber frame, that one has a steel frame. And we straight away, a group of us were looking through there one time, and we said, why did you go for timber here? Wouldn't you think that would burn? And they said, well, actually it doesn't. It's got much higher structural adequacy than this building, because when if a fire was to occur in this building, the steel would get hot and lose its strength, whereas in this building, the timber would build up a layer of char on the outside of those massive big columns. And once you get charcoal on something, it won't burn anymore unless you've got a lot of small timber around it. It's a lot like trying to burn a big log on the campfire, and it just won't burn. You've just got to keep chipping away and knocking the charcoal off. And so that's how they get their structural adequacy for buildings. They use timber to be able to get that layer of char on the outside. It might build up an inch or half an inch of char on the outside, and then it'll stay strong, but the fire would not be able to penetrate any further. Then when we come to look at integrity, that's another rating out of those 3 ratings for the fire resistant level. And the integrity means, in relation to FRL, means the ability to resist the passage of flames and hot gases specified in that Australian standard once again. So we want a building to be able to stay standing, but we also want it to be able to resist the passage of flames and hot gases. You can probably already guess that the reason we want at least those 2 things is so that people can get a chance to get out of the building, or hopefully we can put the fire out before it becomes too entrenched in the area. So let's have a look at what the last rating is on the FRL. And I think where are we? FR. Oops, I might have gone past it there. FRL, can't find it now. There it is. So the last one there is insulation. And if we look at the definition of insulation, in the definitions here, it says in relation to an FRL or fire resistance level, means the ability to maintain a temperature on the surface not exposed to the furnace. The furnace is obviously the part that's burning below the limit specified in Australian Standard 1530.4. So this is going, if we think about those those things, pretty much what we've got here is, we'll go back to FRL. Pretty much with FRL, what we've got is the building is going to stay standing. If it's a 60, 60, 60, it means the building's going to should be able to stay standing for 60 minutes. It should have integrity so that it resists the passage of flame and the heat for 60 minutes, and it should keep the heat out for 60 minutes. So the purpose of that is to give people time to get out of the building, or firstly put the fire out. There's some of the things that we're trying to work with, and that's the FRL. You're going to need to be able to understand that and be able to understand what the terms mean. And you can see there's a little note there. A dash means there is no requirement for that criterion. For example, 90 dash means there's no requirement for an FRL for integrity and insulation. And if there's a dash, there's no requirement for an FRL. So that would be, for example, in a car park, you may not have a requirement for an FRL if it's all concrete, or if there's not likely to be any fire source or something like that. I'm not saying that a car park wouldn't have an FRL, but that's an example of how that FRL works. And we see 3 numbers, and the first one, they're always in minutes, and the first and second and third one relate to these 3 items here. So that gives you your FRL. So we've pretty much covered that. Now there's what we also need to understand is even the National Australian Steel Housing Standard talks about steel framed construction in bushfire areas. I gave you an example of why that's important, because the steel is going to lose its strength once it gets too hot. So Australian Standard 3959 requires that we make sure we allow for that as well. It might require some insulation on the product, something like that. So just depends what the engineer specified. When we come to determining the bushfire attack level, and we're in section 2 of the National Construction Code, there's a few different methods that we can come to. I'll come back over to here so we can find that one through here. We might come back to that one in a second. So if I make that big, you might be able to see that a bit clearer. There we go. So when we come to the bushfire attack level, that's a level called the BAL, bushfire attack level, and it's determined by using a simplified procedure, okay, or a detailed procedure described in Appendix B. So there's a couple of different ways of determining the bushfire attack level. And it talks here about the two methods. This is from the National Construction Code. So let's just have a look at the bushfire attack level. And that's going to take a little while to find that, I think. Oh, spelt that wrong. So Brett was just saying every job they do, they get a fire consultant. That's important. Your engineer is going to give you details with this, but there we go. This is where one of the specialists that you might need to refer to. Okay. So here, this talks about private bushfire shelters. Here's where we talk about building in bushfire prone areas. A Class 1, Class 10A building or deck associated with a Class 1 building, just make a little bit more room here, that is constructed in a designated bushfire prone area. We looked at how you can designate it. It'll probably be with your council, your local government authority designations. Must, to the degree necessary, be able to reduce the risk of ignition. There might be some state and territory variations depending on what they decide is important for it. Then we come to a thing called a private bushfire shelters, which we'll have a look at in a second. And then we come to combustion appliances. So this is pretty much the information here for bushfire buildings in bushfire prone areas. Now I think there's some information here on acceptable construction force. So that's pretty right there. We'll come back to this one. And here's a HIA link for building in bushfire prone areas, and there's a lot of different sources that you can rely on or that you can refer to for information on all of this. They found me in New South Wales. There's plenty of information there. Just really, when you see stuff like this, look to see where they've got the information from. In this case, they're dealing with Windows. They've gone to 1530. In this case, they're dealing with some tests that have been done. Like Mythbusters, as I said, they do tests and things, building in bushfire areas, and then they'll produce it into a document. And you can see here the performance requirement in class volume 2, class 1 to 10 and 10 buildings requires certain things, and that's where you can find your information on that. So this is taken from the HIA, which can be a good way to be able to find the source documents for where you get this information from. There's an Australian standard 353959. And you can use that to divide this, divides into different bushfire attack levels, and we'll have a look at that in a second. I think I've got that there ready to open up for you all. We'll just open up this next one here. So that's pretty much the Australian standard. We might jump on and have a look at that now, and my link probably is dead now because I haven't used it for a while. Yep. I'll just go back and grab that again. So you all understand that at the top of doesn't matter which night you go to for these structures, you can go in and find the Australian standard. You just use your favourite link, or if you've got it up the top there, you just need to put your username and password in. Oh, that might not work. Just make sure you have all this ready so that you're all good to go when it comes to the quizzes. And I'm going to be looking for 3959. Once that fires up, now you might all be trying to jump on at the same time, so just be aware of that, and you might want to download them the morning before or something. I'm just going to type in bushfire because someone said earlier how do you know which number Australian standard? Let's just type in a keyword here and see if we come up with a hit like that. And you can see we've got a whole heap here. Some of this is real technical documentation, which we aren't really interested in. That will be interesting if you want to brush up on your maths, but this is the sort of stuff that the Mythbusters people would produce. Methods for fire tests on building materials. Well, we just want to know the results. So here we go, 3959. That one's superseded, so don't go to that one. But 3959 will be the one we're looking for. And here's one, 3959, and I reckon that'll be the one we'll go with. See how important it's going to be for you to be able to access these source documents so you can answer your questions. And that looks like nothing happens, but it eventually does in most cases. Even an Australian standard for bushfire water spray systems. And there's that's probably 30 results there. That should come through any second now. There we go. This is a fairly big document, this one. We'll see in a second how many pages this is. And this is pretty much 133 pages. So this is pretty much our little guidebook for construction of buildings in bushfire prone areas. Now, HIA, Housing Industry Association, they're going to give us lots of good information, but it's going to be calling on this Australian standard. So we need to make sure that we refer to the Australian standard as much as possible. And pretty much when you get these Australian standards, just skim down until you get to the contents page and make yourself familiar with the headings there. That'd be real helpful, wouldn't it? Determining the bushfire attack level. Okay. And there's a couple of different methods there. General construction requirements. This is going to give us some real specific information like vents, weep holes, gaps, screening materials, glazing, sarking, all those types of things. And then it's going to give us some construction requirements. I'm suspecting somewhere here there'll be some definitions. There's a different bushfire attack levels. BAL means bushfire attack level. What does FZ mean? Okay, I'm pretty sure that means fire zone. So down here we go down, there's going to be lots of information, explanation of bushfire attack levels. Okay, bushfire resisting timber, that'd be helpful to know. Timber species and densities. And then soon after that, we're going to come to the scope. The word scope, at the beginning of every Australian standard, there's a scope, and the first paragraph is your key to what's in here. This standard specifies requirements for the construction of buildings in bushfire-prone areas in order to improve their resistance to bushfire attack from burning embers, radiant heat, flame contact, and combinations of the three attack forms. So that'd be real useful for us right there. So I had a question here. What was that, Kamal? Sorry. The question, Kamal said, there is any use of sprinklers. Let's have a look. Let's see what the standard says about sprinklers. That word is not mentioned in there once. Even the word sprinkler is not in there. So it might mention water system. It's only because of the word that I've chosen. There's way too many there possibly to be helpful for us. Water and gas supply pipes. That probably tells us a little bit about the type of supply pipes that we might need. What's the other term? Can somebody type in the chat box what the term is for a water system that might be used on roofs, because that is used from time to time. Maybe it's a spray word. That word's not in there. Sprinkler. That's not in there. So obviously they might use a different term though within this Australian standard. This is 3.5. I'm interested in what's the difference between active and passive. They don't use that term either. They don't use the term passive. So they obviously have different terms for it. So you can just skim your way through this, become a little bit familiar with it. I'm particularly interested, because I haven't downloaded, I'm not going to get the facility to be able to click directly on something there, and I won't take the time to go through that now. So I want to keep on getting things ready here for you. And I think I was back here tonight. All right, so let's open up a little chat box for you. And this one here, I'll work through this one with you. You can refresh your screen. There's a bushfire shelter discussion. This is, if a client asked you to knock up a bushfire shelter for them, how would you respond? Give that a little bit of thought. And type in there how you would respond. Somebody asked you to knock up a bushfire shelter, how are you going to respond? Somebody said, just knock me up a bit of a bushfire shelter for protection from the bushfire. What are you going to do? I'm going to refresh that in a second. You just type in and tell me what would be the correct response, because you're going to be licensed builder pretty soon. So what's going to be your response to something like that? I'll open that up in another little box there. Just type in there and tell me what you think. Don't too busy firm no. Stick it into the discussion pod there and you'll get yourself a little green box, because by me opening that up, I've just added another little green box to your requirements on the side there. Sam's hit it. I've just got to manage to click on the dot that Sam put in there. Let's have a quick look at what Sam said. Sorry, mate, flat out. So, yep, let's say you haven't got much work. Let's say you haven't got much work and you'd like to be able to lead them into the correct way of doing things and be able to do it correctly. Not a chance unless it's council certified. That's the correct answer. Okay, you need to make sure it's been correctly certified, and you can build it. Okay, depending on the bail rating of the block, I would build it to comply with these standards. Oh, look at that! You can build it. You can all build it. You're just going to have to make sure you consult with somebody and get the right information. Don't build it unless you know what you're doing. Make sure you know what you're doing and just explain to them. I'd go back to the council with them too, and I'd show them that map there. I'd go and say, where do you live? If they say I live right there, if they said this is where I live right here, for example, I'd be saying to them, well, that's probably a bad example because that's an army base and they're going to know. Let's say you're living right in one of these houses here. Look at that. Let's say you're living right there on number 4, Warrawong. If we click on that one and we scroll down here and have a look, we don't need that one so much. You would have to say to them, this is where you live. And so it's real important that because you're in an area where we have a couple more regulations, you'd have to explain to them that they need to make sure they get it all done properly. And that's what you're all putting in there now. So that's real good. Give yourselves a pat on the back, give yourselves a little green box, and well done to all of you. Now I'm just going to show you a news article. This is going to come up a lot in the news at the moment, especially with all of the fires that have been going on. So before we conclude tonight and I hand you over to your activities, just want to quickly show you this news article. I'm not going to read it to you or anything like that. You can quickly skim through it yourself, but this is the sort of problem that can happen. Lionel Bucket here is building a fire bunker in the Blue Mountains, but he hopes he won't need to use it. There's Lionel Bucket. Oh, everybody's saying he looks like me, he looks like somebody else. So Berrambing local Lionel Bucket has nearly completed his own fire bunker in the Blue Mountains, a practice not encouraged by the New South Wales Fire Service. A builder and designer, he constructed the walls from concrete and stone and says they're rated to last for half an hour of flame. Having lived in the area all his life, he said he's seen a lot of fires, decided he would need to be prepared. He's got a couple of apprentices, a couple of workers for him. He's probably quite experienced. Here's his fire bunker. How would you know whether that's going to withstand what sort of fire you can get up in that area? If you've just made something yourself, then that's probably a little bit dodgy. Looks like he's got some professional fittings and things on there. That's the proper fire approved type fitting. And there's a big story there. But pretty much what we need to understand as builders is that there could be some issues there. Now, we need to be able to define a bushfire shelter, and I think we had it on there a second ago, bushfire shelter. Actually, it talked about it down here somewhere. Oh, I just forgot where it was here. Here it was, somewhere here. It was a private bushfire shelter. Here you go. This is a private bushfire shelter. Means a structure associated with but not attached to or part of a Class 1A dwelling that may, as a last resort, provide shelter for occupants for immediate life-threatening effects of a bushfire. Private bushfire shelters, so that's what that tells us a bit about them. And then as we go through, it came to a whole section here on private bushfire shelters, which I think I can click on. Here we go. This is what the National Construction Code says. It must be designed and constructed to provide a tenable environment. Do you reckon that's a tenable environment, what he's built up there, for occupants during the passage of untenable conditions arising from a bushfire event? What's a tenable environment? I would say that's where you can stay for a period of time. Untenable conditions is somewhere where you can't be. Location of the shelter relative to fire hazards, including predominant vegetation. It must be appropriate to the location of the bushfire shelter relevant to fire hazards, including vegetation, adjacent buildings, allotment boundaries, other combustible materials, occupancy of a private bushfire shelter. Okay, so appropriate to the occupancy, to the bushfire intensity, to the fire intensity of, excuse me, having regard to the bushfire attack level, fire intensity of surrounding structures, ready access to it, tenability. There'll be a definition of that somewhere. Generation of smoke, toxic gases, structure of fire loads in topography. It's got a whole heap of information on there about that. So you don't want to build a private bushfire shelter just to die in it. So I'm going to open up this little video now. We can have a quick look at that. And this is bushfire bunkers promise safety, but bring warnings. So that's been opened up, and I'm pretty sure you should all be able to run that in your respective colleges or wherever you are. I'll turn the microphone off here and we'll jump back onto it and finish off when we get back. How are we going? Most people nearly done. Okay, so that pretty much is self-explanatory. There is a performance standard for the bushfire shelters, of course. There's an Australian standard. The ABCB put out a 75-page document, private bushfire shelters, and that's pretty much goes through the details there about, obviously that company probably wouldn't meet the criteria. And if I just quickly go down to the titles page here, I think there was a titles page, you can see the sort of things that are going to be in here. The purpose and role, risk mitigation. We're going to go through definitions of terms, and then it's going to go through some design considerations, the location, general considerations, the number of occupants, bushfire attack level, sealed and unsealed shelters, air supply, what to do about the temperature, fire resistance level, lots of different things. What about the loads, all the different types of loads that could occur? This type of document looks a lot better than the type of document those people used, unfortunately, to purchase their product. It even talks here about the gaps, the doors, the signage. So this is a much more technical looking document that people should use for that type of thing. So when your friend comes to you and says, can you build me a bushfire shelter? A document like this would be a great place to start if it was determined that they needed to have a shelter. As we look through here, there's lots and lots of technical information. So that's available for you on the website there, as you can have a bit of a look at it. Now, there's only a few activities there for you tonight. There's a couple of discussions which we'll do first. And this first one here is about climate zones. And I'm going to also open up the bushfire attack one. And then I'll leave it for you to go ahead and do some of the quizzes. In this particular case, this first activity here is going to ask you about alpine climate zones. And that's going to say, refer to table 1.120, page 20. So this is dealing with the National Construction Code, and define the climate zones for the following. So we've got here Thredbo, Perisher, Smiggan, we've got a whole heap of place there. If we go back to National Construction Zone and type in climate zones, we're going to need to probably start at the top of this document to get the first mentions. And as we work our way through, we'll come to climate zones here, and we work our way down and we come to different towns. So here's climate zones for thermal design, various locations. And as you go back to your plan, you can see, for example, in the discussion, we've got a number of different places. We've got Thredbo there. Here's Thredbo, and that's listed as a climate zone 8. Perisher Smiggins is somewhere here. That's also climate zone 8. Okay, if you look at, for example, Coffs Harbour, that's a much milder climate than 8. So 2 is less severe as far as cold, certainly. And then the higher the number, the colder it is. And you can work your way through and then fill out that little discussion, and your reward for that will be you'll get another little green box. Then the next one we've got here is the bushfire attack level. I'm going to leave you to work your way through that. And then research and find out what your BAL is within your residence. Tell us where you can find this information. So what is your bushfire attack level within your, where you all live, in other words? Find out what your bushfire attack level is. You can do a research and find out from the National Construction Code what that is. That should get us started as you go through. For section 9, 3959, I think I opened that standard up earlier. This one here, was that 3959? Oh no, it was over here, 3959. I'm going to download it so I can get the bookmarks on the side. So you can all work on your activities for that. I'll open up the rest of the quizzes. there for you, and you should be right to work your way through that. If there's any questions or anything, definitely just let us know and type into the chat pod. I'll just open all of this up so you can get your final completions there. Tomorrow night, Brett's going to be doing pools from over at Griffith. And then Thursday night, there's a little bit more